on topic of coordinate geometry, I'm going to do a CSEC past paper question, January 2009, question 4. And the question reads: the diagram below represents the graph of a straight line which passes through the points P and Q. So they give us a graph here. This is the point P and this is the point Q. And the questions on this are: part A, state the coordinates of P and Q. Part B, determine the gradient of the line segment PQ. Part 2, part 2, the equation of the line segment PQ. So we have to determine the equation of the line segment PQ. And part C, the point negative 8t lies on the line segment PQ. Determine the value of t. And the line segment AB is perpendicular to PQ and passes through 6-2. And part D now, determine the equation of AB in the form y equal to mx plus c. Now let us do the first part here. Part A, state the coordinates of P, Q. Alright, so P here is 0 on the x and 3 on the y. So 0 on the x, 3 on the y. So the point P is 0, 3, and the point Q negative 2 on the x and 0 on the y. So the point Q negative 2, 0. The other part of the question now, part B, determine the gradient of the line segment PQ. Now again, P 0, 3 and Q negative 2, 0. And to find the gradient of the line, that's by looking at it. The scale on the x-axis is 1 unit, 1 centimeter to 1 unit, and on the y 1 centimeter to 1 unit. So if I take these 2 points here, what I would notice is that as I proceed upward here, I go upward by vertically by 3 blocks, so 3 units here, and then to come to meet the line now, I go across by 2. So the vertical over the horizontal here, my gradient from this is 3 over 2, right? Now by calculation, the gradient of the line is given by y2 minus y1 over x2 minus x1. The change in the y over the change in the x. So let this be my x1 y1 here, x1 y1, and this will be my x2 y2. Notice if this is x1, the y coordinate must be y1, not y2 but y1. And over here x2 y2. I'm going to get that a little bit larger. So this is x2 y2. And continue now into the formula. y2 minus y1 will be 3 subtract 0 over x2, which is 0, subtract negative 2. This will give me 3 minus, by minus is a plus, so 3 over positive 2. So my gradient is 3 on 2, just as we found here. So the gradient of the line segment is 3, 1, 2. And there were two methods that was used here. Using the formula for the gradient of a line, y2 minus y1 over x2 minus x1, changing the vertical over changing the horizontal. Now we have to find the equation of the line segment PQ. Equation of a line is given in the form y is equal to mx plus c. I already have the gradient, and the gradient from what I saw here is 3 over 2. Right? So I could simply say that y is equal to 3 over 2 by x, and I have to find this value now, c. And c is where the y-intercept, where the line cuts the y-axis. And this line PQ cuts the y-axis at this point here, 3. So the equation of my line immediately is y is equal to 3 on 2x plus 3. Right. So that's the first method. The second method, I could say that y could be either this coordinate point or this coordinate point here. I could use either any of those. So using the point 0, 3 here and the gradient of 3, 2, using the point 0, 3 and the gradient of 3 on 2. Y is given by 3 in this case. 3 is equal to 3 on 2 by x, which is 0, plus c. So this here would be 0. Right? This portion, 3 on 2 multiplied by 0, this would be 0. So we get 3 is equal to c. So c is equal to 3. Equation y is equal to m x plus 3. Same equation as above. Right? So those are two methods that were used to find this. So this is method 1, method 2, and the third method is straight to the formula now. Y minus y1 over x minus x1 is equal to the gradient. I'm using the point 0.03 again. So y minus 3 over x minus 0 is equal to 3 on 2. When I cross multiply here, I will get 2y minus 6 is equal to 3x. So 2y is equal to 3x plus 6. So y is equal to 3 on 2x plus 3. So this is the other method here, method 3. Okay. So the equation of the line, y is equal to 3 on 2 x plus 3. So this is the three methods that were used to find the equation of this line here. The other sum part of it now asks, so we did this part and this part. The point negative 8t lies on the line segment PQ. Determine the value of t. So if this point here lies on the line, this is my x value and this is the coordinate point xy. So given the x value of negative 8, right, given a x value of negative 8, what is the corresponding y value now. Let's go back to the graph. If I say, alright, let me plot it on the graph. -4, -5, -6, -7. Notice that I don't have the -8. But what I know is that as I continue in this direction here, the y values here are negative. So my answer is going to be, for t, is going to be a negative value. Now how do I get that value for t? How do I get that y value? I go back to my equation. The equation of the line is given by y is equal to 3 on 2x plus 3. Right. This line here, the equation of this line is y is equal to 3 on 2x plus 3. So I'm going to use that information now. Y is equal to 3 on 2x plus 3. This is the equation of the line. And I'm going to substitute the value of x here for -8. So when x is equal to -8, what is the corresponding y value? So y is equal to 3 on 2 times -8 plus 3. So y is equal to 3 on 2, 1 by 2 is 2, -4, -4 by 3 will give me -12 plus 3. So y is equal to -12 plus 3. Y is equal to -9. Therefore, the value of t is equal to -9. Next part of the sum now. So let's complete this here. T is equal to -9. The line segment AB is perpendicular to PQ. Line segment AB is perpendicular to this line, meaning it intersect the line at a 90-degree angle and passes through the point 62. Determine the equation of AB in the form y is equal to mx plus c. Right. So this is the point, 6 on the x, 2 on the y. So this is the point 62. Right. This is the line here now, AB. Right, so the line segment AB is perpendicular to PQ, meaning that it forms a 90-degree angle over here and passes through 62. Now, for perpendicular lines, the gradients m multiplied by the gradient of the perpendicular line, let's say m1, m times m1 is equal to -1. So that means that the gradient of the second line is equal to negative reciprocal of the first. And we know that this gradient here of PQ, from what we did before, the gradient of PQ, so let me see where I have that. Right, the gradient of PQ is equal to 3 on 2. So we're going to use that information now. So the gradient of PQ is equal to 3 on 2. So the gradient of the reciprocal line now, sorry, the gradient of the perpendicular line is the negative reciprocal of this here. Right. So that means that if this is positive, then the gradient here is negative. Right, so this gradient here is negative to start with, and then the reciprocal means that you flip the fraction. So this is -2/3. So this is m, This is the gradient of the negative line. Let us call it M1. So in this case, M is equal to 3 on 2. So M1 is equal to 2 on 3. Negative 2 on 3. Now, let me come back to this here. M times M1 equal to minus 1. So M is equal to 3 on 2. M1 negative 2 on 3. Multiply both of them. Right? 1, 1, 1 and 1. 1 by negative 1, negative 1. So I got negative 1 there. So M1 is equal to negative 2/3. And the point is 6,2. So using the point 6,2 now, and gradient of negative 2/3, I could find this equation here. So I know that y is equal to negative 2/3 of x plus some value. I am going to find that value, which is c. And to find that value now, I substitute for x and y given here as 6. This is my x value 6 and this is my y value 2. I substitute into this equation here for x and y, and I'm going to find this value here, the unknown. So we're using y as 2, negative 2/3 by x here, which is 6, plus, and this unknown is c. 1 3 is 3, 2 3 6, 2 by negative 2, negative 4. So 2 plus 4 is equal to c. So c is equal to 2 plus 4, which is 6. So my equation, y is equal to negative 2/3 of x plus 6. So coming back here, determine the equation of a being for y equal to mx plus c. Y is equal to negative 2/3 of x plus 6. And that is the question, the answer for the 2009 question 4.